Hi, my name is Justin Berrier, and for the engineering design class 496A, I decided to design and create a tennis racket stringer. As you can see here, I made a quick assembly to show you what the final product will look like. There's a turntable down here which can rotate, and on that are these posts which can translate along that turntable. On the top of each post there's a little rubber section, the black rubber section, which is where the head of the racket will sit, and above that is a plate in order to hold down the racket head too, and that also consists of rubber on the bottom, prevent racket from moving. Above that is are some plates in order to use for different size head rackets in order to hold them in place, and above that is the knob to tighten down all of these parts, which is on a pin. On the other side there's the winder, the string winder, which sits on the blue base by use of rails. The rectangle parts where screws would go down I left out because for performance purposes would slide into place on these rails, which you can see the protrusion right there, and then slide in there into the base. Would hold the winder stand in place, and on the winder stand there's these bearings which will allow the weight bar to rotate. On the weight bar there's a weight which can be bolted, twisted into place, tightened for specific tension needed. And down here the blue part, the string would come around, go through this midsection, and the blue part on the bottom will move out, and then you push it back in with your thumb, and then use your other hand for fine adjustment using this knob and gravity, and you get the required tension you need. And winder stands made of aluminum and such. These parts over here, the turntable and posts, are made of steel. The blue base had a lot of cuts and reference features. It started out with a loft, as you can see, an angle loft, and then swept cuts. On the bottom there are adjustable feet, which are attached using their guide rail systems and their rectangular brackets. In addition, the turntable was extruded below, and that's just for structural purposes. Two hard parts to make were the posts. As you can see, they took a couple angles, lofts, and cuts, and this is where the turntable will come through, be screwed on right there. Three parts were made from each: the rubber and the two steel parts, the post and the pin, which took a lot of features you can see over here, and the fillets are for realistic visualization. In addition, the winder stand took some time because there's a lot of dimensioning needed, but a lot less features required, as you can see. And all these angles had to be dimensioned in reference from the circle, say, and that took a lot of time. Over the course of the project, history was taken into account a lot. As you can see here, for example, I wanted to move this insert over here. Instead of drafting up a new sketch, I used the mirror entity using the right plane and really quickly used symmetry in order to come up with new cuts, extrusions, whatnot. And in addition, I used reference geometry. You see here, I used 45-degree plane to make a reference cut. I did it a couple of times, and that was for where the string will smoothly come into the clamping position. In addition, I used a lot of patterns. This one has a circular pattern for the finger grip. Made this cut here, and instead of doing a lot more of the same cuts, I used a circular pattern to get it done in one shot, one feature, and cut down on design time. Using converted geometry, I cut down on the features required. As you can see for the guide rail where the protrusion sticks out, instead of making a lot of new sketches to do that, I used converted entities, which you can see in this sketch, not that one. In this one, I converted features, I did some offset entities, and then made a couple of dimensions, but a lot new relationships in order to cut down on time to make the feature. In addition, I used on-edge sketch relationships. Here I wanted to make an angle cut from an original rectangle. Instead of making a lot of lines and doing a lot of dimensioning with that, I just used on-edge relationships, and all I needed was one dimension in order to make this cut, which literally took 15 seconds. And on this for the project, I used variables since a lot of the parts were related to each other. And here I show an example of linked variable, since the loft is symmetrical. Instead of doing dimensioning all over the place, I use a linked variable and it'll dimension both sides evenly. Also, I use equations. Here I have the gripper drum, and I use the equation in order to find the placement of the screw holes directly in the middle where the bearing hole is and the cutout. And there's the equation I use, and I use that multiple times, different parts. I use the hole wizard a lot. Here I use the hole wizard for cutting out this hole, and this is the part where the string will be held in place with your thumb, so it has to slide along this oval part, and then the hole wizard cut down on feature time and design time. Some software limitations and stuff with this project. When I was designing it, actually I wanted to put helixes and grooves for these screws, but since my computer poorly performed and slowed down and got sluggish, I just I decided to get rid of them. So that was a software limitation. In addition, another challenge I came across was making a plate. This loft in the beginning, this circle loft. There was a little section that stuck out at the back here, and I got it to an infinitesimally small thickness, and I wanted to make a sketch just cut that out, but the program wouldn't allow it unless there was a thickness, which I did. I applied a thickness at the end, and then it cuts it out. And for the final project, some improvements would, over the design, be more of a lifelike bearing system I want to apply. Apply better bearing system through here, and also the locking mechanism inside here consists of a gear and a tooth, and that requires some more knowledge of assemblies for me to figure that one out. In addition, some refinement for like aesthetics, some decals and whatnot, and refining on the exact materials used. I just chose the basic ones from the database, like aluminum here and steel and the rubber, plastics. And for the final project, I'm going to have to refine that and get more exact materials. Well, that's Tennis Racket Stringer made by Justin Berrier. Thanks.